Hey YouTube, Kavix here. So the purpose of this video is a quick demonstration of constant image height using an anamorphic lens. The image that we've got on screen now is 16:9 and it has a few horizontal line markers indicating different aspect ratios. The most inner set of lines is 2.39 to 1. That would represent your typical edge of your black bar, top and bottom of a movie presented in CinemaScope. While CinemaScope is supposed to represent a bigger image than your TV, on home video formats, letterboxing has actually made the image smaller, not bigger, because the video system is confined or constricted to the width. There are ways around this. With a video projector, you can either zoom the black bars off the screen, or you can employ an anamorphic lens as I have. Now there are two ways to use the anamorphic lens in your system, either leaving the lens in place all the time as I do, or you can fit the anamorphic lens to a sled and move it out of the light path for 16:9 content. Both have their pros and cons. One of the reasons I choose to leave the anamorphic lens in place all the time is because the anamorphic lens introduces a type of optical distortion called pincushion, and pincushion creates curvature at the top and bottom of the image. To correct this needs a curved screen. So what I've been able to do is create a system where the curvature of the screen precisely matches the amount of pincushion introduced by the anamorphic lens. And to the naked eye, straight lines are once again straight. The camera shows them as slightly curved because what we're actually filming here is a 3D space, not a 2D image. So to quickly demonstrate what happens, the anamorphic lens itself optically expands the image or stretches the image. But of course in doing so, the geometry is all messed up. As you can see, the circle is now an oval. To offset this horizontal stretch, we need to apply electrical vertical stretch or scaling. When scaling is employed, now we have geometry correct imaging with our anamorphic lens. What you also will notice is that those lines denoting the black bars are the only lines visible on screen. All the little markers, the lines themselves aren't visible, but the markers themselves are now visible. So all of that information that was present in the in the video when we first started would basically represent black bars on a letterbox video. The combination of scaling plus optics allows us to remove those black bars and present the image wider than what the original 16:9 frame is. So just switching between the modes, you can see that the height of the image doesn't change. The width certainly does, but also what is removed is all that information which is denoting the aspect ratios. But you have to remember that information is wasted information on the disc because it's just black. So there's CinemaScope and there's 16:9. The height remains the same, the image width changes, hence the name constant image height. If this video has been useful, please give it a thumbs up and we'll see you in the next video.